This is the first video on Chapter 5 in the Pure Year 2 book, and it's on the topic of radians. By the end of this video, you should be able to do exercise 5A on page 116. I'm going to show you how to convert between radians and degrees and back again, and hopefully you'll understand it. So what radians are is they are an angle. They are a measure of turn through a circle, around a circle. And you're probably so used to using angles in degrees that for you it might be hard to think of them as being anything other than 360 of them in a full circle. To you, probably a right angle just is 90 degrees. It's going to be a little bit strange because you're going to find out that it's not only 90 degrees, it can be measured in other ways too. So get your file paper in front of you. Make sure you're going to take notes, and I'm going to share my screen with you to help take you through this topic then. So your title then, Degrees and Radians. As I've already said, an angle is a measure of rotation, and that system of using degrees to measure radians, to measure angles, we think it came from the Babylonians, this concept of 1/360th of a full turn. It's a little bit of an arbitrary number, isn't it? 360. So why is it that we measure an angle in 360ths? Well, possibly because the ancient Babylonians, they developed the calendar, and it's very close to the number of days in a year. That's one possibility. Or it might be partly as well due to the fact that 360 is a very divisible number. You can divide it into quarters, into thirds, into fifths, sixths, 12ths, 20ths, 15ths. A lot of numbers divide into 360 without leaving a remainder. So therefore, it's a very useful one if you're going to do a fraction of a circle. So you end up with a whole number of degrees, even if you do a random fraction like 4/9. That's equivalent to 360 degrees. But what if we don't split a circle into 360 parts? So this is what 1 degree looks like. In fact, that's a little bit large for 1 degree, but it's 1/360th of a circle. If instead, though, we define a new way of measuring an angle like this. This is a radian. So this is the definition of 1 radian. 1 radian is the angle subtended at the centre of a circle, where the arc is the equivalent of the radius. Now that looks a little bit like an equilateral triangle, but one side is curved. So you can see that it looks close to 60 degrees. Well, let's delve a little bit deeper into what 1 radian actually is. So here's 1 radian. Let's see how many of them, therefore, will fit round a full turn, a full circle. There's our 2nd, 3rd, 4th, 5th. 6 and a bit fit around a circle. So that doesn't then seem like it's such a useful measure, because you can fit 6 and a bit into a circle, not a nice round whole number. Well, let's think about it a bit more clearly. Let's think about a semicircle. So a semicircle, half a circle, is going to be 3 and a bit. There are just over 3 radians. Well, to be precise, of course, there are 3.14159 or pi radians in 180 degrees. And now this is starting to make a bit more sense as to why radians are so useful. Because, of course, in a full circle, you know the formula for the circumference of a circle, c is equal to 2 pi r. Of course, that means that there are 2 pi radians in a full circle in 360 degrees. So that's our first point of reference. First thing that's useful to note down, to remember, is that 360 degrees is 2 pi radians. Okay, so as I've said, a full circle, full turn is 2 pi radians. That means that to find out what 1 radian is, about it, 2 pi radians is 360 degrees. So if I want to find out what 1 radian is, divide by 2 pi. 360 divided by 2 pi turns out to be 57.3 degrees. So it's close to 60 degrees, as we said at the beginning. That figure there, 57.3, you don't particularly have to remember it. It's more useful to remember that 1 radian is just a little bit less than 60 degrees, as you can see in this diagram here. Well, let's have a go at actually converting. Note down, if you haven't already, that 2 pi radians is 360 degrees, or in fact, I think it's more useful to remember that pi radians is 180 degrees, because you can work up and down easily from there. Now, you usually see radians expressed as a fraction or a multiple of pi. So, for example, pi over 2 radians, all we need to do then is divide that by 2. So therefore, 180 divided by 2, it must be equal to 90 degrees. So therefore, if I wanted to do a less familiar fraction like 5 pi over 6 radians, what I've done is multiplied that by 5 and divided by 6. So I need to multiply 180 by 5 and divide by 6, and that gives us 150 degrees. So if it's not given in terms of pi, if you just have a random value, for example 2.5 radians, then all you need to do is multiply by 180, divide by pi, and you get 143.24 degrees. Not a nice round figure, but you can see them given as decimals as well. Now you might find that this is a good way of remembering it. So if you have to go the other way around, if you have to go from degrees to radians, do the reverse, use the reciprocal. So therefore we're now multiplying by pi and dividing by 180. 60 times pi divided by 180. You probably won't do the cancelling down bit, you'll probably just reach straight for your calculator, and that gives you pi over 3 radians. 200 degrees multiplied by pi, divide by 180, gives you 10 pi over 9, or 10/9 pi radians. Okay, but if it's not, if it's a decimal, 37 degrees, for example, multiply by pi, divide by 180, give your answer to 3 decimal places, 0.646 radians. Here you can see that the little letter C is given as a way of symbolizing radians. You don't see it so often, usually it's RAD, but you might see it given as a small c, so do be aware that's a possibility. Okay, as it says there. Now, let's see if you can do this one then. So 337.5 radians, what is that equal to in terms of pi? So it's a little bit less than 360 degrees, so you'd expect it to be a little bit less than 2 pi radians. So see if you can work out which of those is. And in fact, now that by clicking it, it should have given you the answer there. It's actually 7 pi over 4. Okay, now have a go at these ones. This diagram here is a really useful way of remembering it. So I would copy this bit down. If you start from 180, this is obviously degrees, that's obviously radians. If you're converting from degrees to radians, divide by 180 and multiply by pi. If you're going the other way around, from radians to degrees, divide by pi and multiply by 180. So I would take that down, then pause the video and see if you can work out what these are. And when you've had a go of it, restart the video. I will give you the answers. Okay, so you should have done those by now. 90 degrees then, you should have worked out that's pi over 2. That came up earlier. 135, that is 3/4 pi. Pi over 3 turns out to be 60 degrees. 3 over 2 pi is 270. 45 degrees, you should be able to get that directly from this. It's just half of that, so it must be pi over 4. 72 degrees is 2/5 pi, or 2 pi over 5. Pi over 6, well, that's just half of this, so therefore it must be 30 degrees. And the last one, we did that one earlier, in fact, 150 degrees. Some of these are worth remembering. The pi over 3 is 60 degrees, is worth remembering. 3 pi over 2 is 270, also worth remembering. 45 degrees, try and remember that one. And 30 degrees is pi over 6, also worth remembering. Let's just take a quick look at how that affects the graph of sine x and cos x. So the sine wave here, you're used to seeing that as being 90, 180, 270, 360. If you're writing it in radians, of course, that's going to be pi over 2, pi, 3 over 2 pi, and 2 pi. Likewise with the cos graph. So you often see them given just in terms of pi in radians there instead of degrees. You should be in a position now where you should be able to do that exercise that I mentioned earlier. Just as a reminder, it's exercise 5A on page 116 in your textbook.